Okay, so here we are with a piece of brass. This is 1/8 inch thick brass. Bronze would be better. Steel would be okay. Cast iron would be okay. Just this is what I have in the shop. It's a little bit wider than we need. We'll have to cut it down for width, which we could do either first or second. So I'm going to do it second. And now let's think about what it is we're trying to achieve. So the beauty of this system depends on the angled end of this part. And this has to be the same angle as we find in between the two surfaces on the Spokeshave body that we filed. And so we need to create some kind of gauge that goes in there like that. And this gauge is going to be very useful to us in replicating this angle. Well, just a piece of plastic that I cut. I did measure it. As you can see, it's 57 degrees. It doesn't matter exactly what it is. It just has to be the same as the body. And they're all about 60-ish degrees, all the A151 Spokeshaves. But should make your own gauge. It could be out of anything. It could be a piece of wood or anything that allows you to measure and capture this angle and feel like you really got it right. Okay, so useful tool. And by the way, I started out with, I have an assortment of angle gauges and stuff, but it's an awkward little thing to measure. So all I did was put this 45-degree thing in there and tried to think, well, yeah, it's maybe a little bigger than that. So anyway, that's somehow we got to 57, and that's a good thing. All right, here's our piece of stock. And we're going to create another part just like this one. All right. So a couple of ways we can do this. Here's a cheap and cheerful little strip sander, a 1-inch by 30-inch sander. We're going to spend some time with this machine in episodes to come and show you how useful this is. And I think I already made my little rap about this, that the abrasives that are on belts these days are just awesome. They do a fantastic job. Way better than they were decades ago when I started. And obviously to do this, we just turn it on and then, don't press too hard because we don't want to change the setting. But and so on until we get a chisel edge that's the correct angle, right? And then if you don't have this sander, and sort of in the spirit of, was trying to figure out how to do this with a file and a hacksaw instead of a milling machine. Now we can just put this in a vise and try and get it to line up with our, whoops, there we go, ish. Trying to get it to line up with our, well, that's pretty good. It's just a visual anyway. And then with a file, you can think about your favorite thing while you do this. So this is some pretty good filing technique I'm demonstrating. So we're trying to use the whole cutting surface of the file. This is one of my favorite files. Again, this is a 10-inch cant saw file. Again, the name is because it has canted surfaces on it. There's no such thing as a cant saw. Single cut file. And pretty efficient. You can see the Material's coming off pretty quickly. And because we set it up so that it's sitting at the right angle, hopefully we can work in a disciplined way and keep the file parallel to the floor or something like it. So filing brass isn't too bad. Brass cuts freely. As you can see, it's not clogging. And we've got this nice filing dust or swarf that's coming off. And I promise that I'm going to finish this up, but I won't make you watch the whole thing. Okay. Okay, so here we are. The next step is we want to make sure that this is really the right angle. And we also need to get a terrific finish on this. This is one of the keys to why this arrangement is going to work so well for us, is that we're going to have a really beautiful, smooth surface here that we'll play around till we get a really nice, shiny surface so that it doesn't tend to catch and grab the shaving as it's passing its way through. This is an old-fashioned plain chisel honing guide thing. I don't know if you have one like this or something like it, but it's designed to cut low angles, like 25 degrees or whatever it is that you're doing for your chisels and planes. But of course, this is a very different angle, so you can use a chunk of whatever you want, piece of wood or something. And the idea is now we're going to try and set it up so that we can mimic this angle that we've measured and made a template to do. So let's see what we can do here. I think that's looking pretty good. Okay. And now we'll need a piece of sandpaper here, and we're going to just be super careful to not rock this part while we're cutting on it. Make sure we get a nice flat surface. Of course, we're using a flat surface, which if you don't have a surface plate, you can just get a piece of 1/2 or 3/4 inch plate glass from your local glass company. Go bring them a coffee cake or something and see if you can get a scrap. Those are really flat surfaces, and if you can figure out how not to break them, they'll give good service for a long time. You can see that my belt sanding was a little bit off, but we're going to just persist and sand this until we've got a good clean surface all the way across. Okay, so it's cutting here, and we got to cut this until we get back to that surface. So this is a little fussy, but again, this is the key to the success of this tool, and it's super important. We take our time, make sure that this comes out perfect. The nice thing is all we have to do is create one angle that's correct, and then our cheap and cheerful clamping system is going to make sure that everything lines up perfectly, and we'll get a chance to solder it in position. It'll come out super precise. Getting there? Getting there. Almost there. Very, very close. Okay. So now we have one land that's at the right angle, but at 150 grit it's too rough. So we'll get some finer paper. I think this is 500. Okay, most of the way there. We need a new piece of sandpaper. So we'll put down a piece of 500 grit paper. Finish this off. I'm just playing around, making sure that we have a perfectly flat land on the end of this piece of brass. Okay. I'll try one more direction. Just make sure all the scratches tell us that we've got to the truth of this. Couple more cuts. All right. That's what we're looking for. With 500 grit. If we want, we could go farther. That's probably okay. Bitty little scratches. Okay, this is good. Oh, that's some nice surface right there. So what was this? 1,500. That's got to be enough. That's great. So, game over. This would be a time, if we like one corner better than the other, to decide which one that was, because we have to cut off one corner. I don't really see any difference. So, use the caliper for a scribe. All right. So we can either use a hacksaw or a file or our little wind belt sander. All right. We're going to cut down to this line and get ourselves in the neighborhood here. Okay, tiny bit oversized. That's fine, we'll just nick it with a file if we need to. Oops. Yeah. Oh, it's a casting, of course, so there's always little issues, little problems. This shape. Back corner's hanging us up a little bit. Okay. I think that seems okay. And still be a little bit of interference on this front corner. Anyway, you get the idea. Just kind of don't take off more than you need to, but it's not terribly important that it doesn't have to be a perfect fit, but we'll do a good job, huh? That looks good. Okay. The next thing we'll do is put it all back together with the blade clamp and mark it to cut the top end. So we do a nice job and have it come out even with the Spokeshave casting. All right? So here we are where the rubber meets the road. I know this looks a little crazy right now, but this has worked out beautifully well. And why don't we look into this and see what we've got? First of all, here we have our brass insert slammed up against this nice flat blade. We put the blade in backwards because it's just a little bit more convenient. The other thing is that while we're heating this up, if we were to get the blade a little hotter than we needed to, who cares? It's the back end of the blade. If we take temper out of this, I don't even know if we can take the temper out of it with a little amount of heat we're using. The solder that we're using is going to flow at about 450 degrees Fahrenheit, which may have no effect on this this beautiful steel that we have here. And then we can see that there's a little gap here, which is fine, which we can explore that in a minute. And then we look over here, and we see that the sharp edge of this blade, this flat side up, is has cut into this piece of brass and is forcing it in the proper direction, that is down and forward. So down, it's forcing it down onto the blade surface and forward up against the cast surface here. So here's got a 2 3/1000 shim here. We can see the 2/1000 shim is coming through just from here to here. So that's a 2/1000 gap there. And then here's our 3/1000 shim. And this isn't making it. Oh, that makes it just in one place. Okay. It's here and there, but it's only going through this one little spot here. Now, in order to get a bond with this solder, we're going to need the solder to flow in there. And we can't, if we have two perfect surfaces that touch perfectly, we won't have any flow. The flow will never get in there. In this case, we're going to solder by adding solder from the outside in this direction. And so, because of the way it's clamped, we can't choose to introduce the solder into here first and then heat it up and see what happens, because we need this clamp to be super tight. And remember, we're clamping this sacrificial blade with these fender washers and inverted Spokeshave adjusters to drive this blade in. We won't be able to move this or chase this while we're heating up. It'd be too hot, too dangerous. So we need it to be exactly in the right place when we introduce the solder, okay? So this we've got pretty tight. And we'll use the feeler gauge just to check a couple other things. We've got the number 2 feeler gauge here. We're going to check in between the shim stock and the blade. And remember, we filed this a little bit hollow, and sure enough, there it is. The 0.002 feeler gauge blade is going in just in the middle here. So we have the blade is touching hard here. Okay, that's not going in, right? Because that's where it would be. That's not going in there, and it's not going in there, but in the center, it's going in. So we feel like we're pretty sure we have about a 0.002. Yeah, and the 3 isn't going in. So that's great, because that means the blade, when we're using the tool and we clamp it in, the cap is going to clamp onto the blade, and it's going to touch here and here first, and then we're going to be able to squeeze it in the middle, show you that later, and deflect the blade, and it'll make it even more rigid and solid in the tool. So just a couple of tiny little relationships are going to help us achieve nirvana with this little close shaving tool here. So again, let's look at this. Finally, we're going to look at this gap, and this is where we're going to need to put solder. So you can see there's a 0.002 gap here, and a little gap there. It's not coming all the way through. Here's the 0.003 blade. Again, there's a little gap here. Anyway, that's fine. We're going to expect to see the solder come through to some extent on the bottom here, okay? The only thing that's left, now we've checked and okayed this, we're going to take our scribe and make a mark, and then we're going to saw this part off on that mark, and you could see that it's mark it on the ends also, depending on how fussy we want to get with it. It doesn't really matter, but it's going to be our tool for a long time, so we're going to do a job we can be proud of. All right, so last job, cut the part off the stock and get it ready to solder in place.